What is up, YouTube? It is day 14. How's it day? It's not looking good the last couple of days, but we're on day 14 of JavaScript with Joe. We're going through these 25 coding challenges. If you beat them, you get these 2 stars. If you sort of half do them, you get 1 star. If you don't do very well at all, you get no stars, and it seems like I'm on a bit of a losing streak. So hopefully we can beat that today. So that's adventofcode.com. I'll just share that in the chat. And today I'm doing day 14, which I'll also share in the chat. And my code will always be available on replit.com, which I've also shared in the chat. So this is just a website where you can very quickly start writing JavaScript or Python or whatever other language you want to use. I'm going to be using JavaScript today and hopefully solving one of these challenges. So let's get into it. If you are watching, feel free to type in the chat to say sort of what level you're at or what language you're even programming in, and I can try and sort of tailor it for you. But yeah, let's get started. So day 14, extended polymerization. The incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization equipment that would provide suitable materials to reinforce the submarine, and the nearby volcanically active cave should have the necessary input elements in sufficient quantities. The submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules, which is your puzzle input. So every one of these challenges comes with a puzzle input that's unique to your login. So none of you should have this, and hence my answer will probably not be the same answer that you have. Okay, you just need to work out what polymer would result after repeating the pair insertion process a few times. For example, the first line is the polymer template, so that's this NNCB. This is the starting point of the process. So let's just write this in here. So I'm just putting 2 slashes at the front to comment it out so it doesn't affect the code I write. The following section defines the pair insertion rules. Rules like AB to C means that when elements A and B are immediately adjacent, element C should be inserted in between them. Okay, these insertions all happen simultaneously. So starting with the polymer template NNCB, the first step simultaneously considers all 3 pairs, the pair NN, the pair NC, and CB. That matches this rule and inserts a C in between. The second pair, I guess now there's a C in between them, but we're not talking about that. NC matches the rule NC to B, so B is inserted between them. The third pair matches the rule CB H, so element H is inserted between C and the B. Note that these pairs overlap. The second element of one pair is the first element of the next. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of a pair until the next step. After the first step of the process, the polymer becomes NCN BCHB. Here are the results of a few steps using the above rules. This polymer grows quickly, so this is sort of a clue that this might be something that becomes exponentially difficult. So we might not be able to cut as many corners as we'd like. After step 5, it has length 97, after step 10, 3000. And after step 10, we've got the counts for different polymers, I suppose they are. Taking the quantity of the most common element and subtracting the quantity of the least common element produces our number. That's probably our answer. So we're applying 10 steps of this and then calculating that answer. So we can probably cut some corners for the first half. But let's see where we get. So let's work with this input first. And first thing I'm going to do is just see if my input code from the previous weeks is useful. Kind of is. So our first one is our template. So let's save that as const template equals input 0. So that will get us the first item from that list there. So we've got our template, and our rules are less easy. So we want kind of feels like I should put those in an object. I'm not sure if it doesn't look like there's at a glance any duplicates. which kind of makes sense. Maybe you have to have the rules for all possible combinations. So let's say const rules equals input. That will be from the second one up to the length of the input. Oh, I can't do that. That's Python. Dot slice to up to the input length. Should be slice. So now rules should be accessible when that does run. Just going to refresh it because it seems to be hanging a little bit. Ooh, spelled slice wrong again. Rules, got it. Right, is that the first rule? CH to B, yes it is. CN to C, okay, cool. So I've not missed any. Next, I probably want to make some sort of rules map. So I want an object of the format CH B, like this, and that way I could say, oops, CB H. So if I have this object, I'll be able to, let's call that rules map. If I have that object, I'll be able to say rules map CH, and it will return me rules map CH will return that B, so I can just use that sort of as a function, but I have to write something that's going to convert this rules object into our rules map. So I'm going to do rules.forEach rule console.log the rule. Oh. For each is not a function. Can I not call the for each on a list? Surely I. Oh. Rules is not defined. Rules is not defined. Input is not defined. What's happening? Is that just because this is erroring and then it's not running? Ah, it's because I put an uppercase F. Right, let's try that again. Cool, there's our rules. Let's now do rule dots. So let's say, I don't know, parts equals rule dot split arrow with the spaces around it. So that will make the first item in this list our CH, the second one our B. And then I should just be able to say rules map equals rules map parts 0 equals parts 1. So I don't need that anymore. I don't need a rules map, but I do need it to exist before I start putting stuff in it. Now I should have a rules map. Ta-da! Looks similar to our rules, CH to B, CN to C, which is what we got here, CH to B, CN to C. So now I've got my rules map. Next I need to start making my pairs. I guess I could just, how am I going to do this actually? I'm basically just looping over the list with sort of a sliding window. So I can use a for loop, I guess. So move our window. What does it call them? A pair, I guess. Over pairs. pairs for x, let x equal 0. So we always want to start the first one. X is less than template.length minus 1, because we want to stop 1 early, and then we're just going to increment x. So now if I do template x, that should give me my first character, and then c, which is right, and then if I do plus template x plus 1, that shouldn't be erroring. And there we go, so those are our pairs. So now we just need to put those pairs into the rules map. So let's say let pair equal this, and then we should be able to do, so log the pair, then let's console log the rules map pair, and that should give us what we're inserting in. So we should get CB, well, we got CBH. What did it ask for? C, B, and H, cool. Now we just need to insert them into the right position in the string. How am I going to do that? How am I going to do this? Because there is an overlap there. So I guess I can... put the, like, no, that doesn't work. Just thinking I could put like the first character in, no, the first character of each pair until I get to the last one, then I just put the last one in. That could work. So I could do like let next polymer equal this, and then I can do next polymer plus equals template x. Then I want to add the let new, are the polymers? What am I even putting in? Let insert equal rules map pair, next polymer plus the insert, and then on the last one I think I just need to add the last item of the template, so I need to do next polymer plus equals template length. Oh, then next polymer, template length minus 1. There's a question. Next polymer, cool, NCN BCHB, and we should get NCN BCHB. Cool, so that looks like it worked. So I just need to wrap this up into like a step function. So actually let's tidy up a bit. So let's say first poly equals template x, second poly equals template x plus 1. Now let's replace this wherever we use it. Oops. There, get rid of these console logs. So we're inserting after we find our pairs. Add final character in. Then let's wrap this all up in a function. Const step equals, let's put the step insert. Step insert is equal to no, step insert needs to take a template, it needs to equals template, it needs to return a new template, but we'll do that in a bit. So it should be returning this next polymer. So you can play oh, I need to spell return now. Okay, so now I should be able to do step insert template console.log step insert template console.log template, and that should, there we go. So now I should be able to try it again with that. I guess I can just do this and wrap it in another step insert. I'm not sure what that'll do, but so I feel like I've got a leaky, I am calling a lot of things template. Okay, mbccn, that looks pretty good. So now I need to do this 10 times. So for step, let step equal 0, step equal 1 actually, step is less than 11, step plus plus, console.log step step console.log step, then let's do let new template equal step insert, and needs to be an old, what do I do here, a new template equal template, and then new template equals step insert new template. Is this going to overwrite? No, it should be okay. Let's see. And sort of log new template. Right, I should have expected that was going to happen. Let's bump it down to 5. Okay, so I've got a couple of extra console logs. I didn't need these. BHCB, that looks good for step 4. I just need to make sure that I am counting up to 10, which I am. And then instead of logging this, I need to count the number of each character. So new template is now 10 steps in. Oh good, we're only 20 minutes in as well, and I actually get this done. Now I need to count the characters in each. So I guess I'll write my char counts equals this. Can I use like for char in? For character in string JavaScript. It's not like a for each. Oh, okay, I'm not going to do that. For let char equals 0, char is less than new template dot length char plus plus console.log char. This should be quite a lot of characters. Oh, new template char 3,000 characters we're looking at there. Okay. Let's call that punch char equals new template I if it's already in there, we need to increment, otherwise yeah, it should say does not exist every time because it's not in there, so then I need to say char. Oh, if it does exist, well, it doesn't. Okay, so if it doesn't exist, I need to say char counts char equals 1, and they should all equal 1, and they should all exist by the end. Yeah, char counts. Cool. So now it does exist, so I can say char counts char equals char counts char plus 1. That should get us our counts. 1749, 161, cool, looks good. Get rid of the console logs. So now I can trust my char counts. Now I just need to get the min from my char counts. So I can get my, I guess I don't care about my keys at all, so I can do object.values of char counts. That will just get my numbers. Dot for each char count console.log char count. There's my numbers. Now I just need a min and a max of those numbers. So let min equal -1. Let max equal -1. I should probably do the opposite of that. Probably need like big number. Then I can say if char count, if char count is less than min, then min equals char count. Else if char count, oh, it's not doing else if char count is greater than max, then max equals char count. And then I should be able to do console.log max minus min. 1588. 1588 looks good. Let's try it with our puzzle input. And if it does go wrong, well, it might not finish because it might be a much bigger value, but we'll see. Oh no. I mean, that seems okay. 2375. So if it is wrong, I'm imagining it's off by 1 probably. There we go, 1 gold star. I've not got one of those in like a month, so thanks for watching. But that's actually only halfway there. So every one of these has two parts. Normally the second part will punish you for all the corners you cut in the first part. So we'll see the resulting polymer isn't strong enough to reinforce the submarine. You'll need to run more steps of the pair insertion process. A total of 40 steps would do it. Okay, so it's a much bigger number. So we can go back to our original input, and what we'll probably see is that 40 takes a really, really long time to run. So let's see. Yeah, so we can see already that at only 20 in with our smaller polymer, it's just taking a really long time. It probably, I mean, you can see the CPU is full. It probably will finish in a couple of minutes. Thanks. But yeah, this is what all these challenges are usually designed to do, is to punish the ways you've cut your corners. So the question is there a quicker way? So I guess looking at what we've done so far, so splitting all the rules, this isn't really the problem. The problem is when we step over it, we are breaking everything down and building up an entirely new string when we could probably be, I don't know what we could be doing. Ooh. So, I was calculating such a large something there that it's just broken. So we need to do something sort of, I don't know actually. I'm open to ideas, Eunice, if you have anything. This is where they fall down a bit. So I guess what am I doing here that's actually the problem? That's computationally intense. Let's have a look at what we're doing. Sometimes I find it useful to draw these things. So we've got our string, say n, c, b, and we're breaking that down into n, c, cb. That process is not too bad. I mean, what we're doing there is we're basically iterating over the entire thing, and we're saying that's a pair, that's a pair, and that's a pair. So that's kind of linear anyway. They're both kind of linear. I think the problem is that it grows exponentially each time we do it. So then I would say, is there a quicker way to get all the pairs out than what I'm doing? And what I'm doing is just accessing them one at a time. I guess, right, what we haven't done, no, the order does matter. Right, let's go back to this, because I think this will help. So what I'm thinking is that what we're actually looking for at the end is still just a count of the most common elements. So I suppose when we break each one down, we know what's going to be inserted in between it. So NCN. I'm just going to write this next one. NCN BCHB. So when we break this down into these, we know that this is going to become NCN, NBC, and CHB. Which means that from that point, we should already know that this is going to become the pairs NC and CN. And we know this is going to become NB and BC. And we know that this is going to become CH and HB. So that is the bit that's exponential, right? Every time we're splitting these, they're going to split into two, they're going to split into two, and so on. So is there a way to, from the initial Just thinking, like, we can't, if I just follow it down a tree, does that actually, I don't feel like I'm doing anything less computationally intense other than not trying to store one big string, right? Like, all I need to do is find the counts at each point, but I also need to preserve the order a little bit just to make sure that I'm not I guess there are some, where is it? There are going to be some that you insert, so, oh, I don't know. I should have known it when I was reading this bit. I mean, I did know it, but I was hopeful. I guess I would, I mean, if I didn't care so much about the order of each pair, then it would be easy. There's something about, maybe I should write it through a little bit more. So let's see. NNCB. We have that as sort of the seed to our first part. So that becomes NCN, which then becomes NC, CN. I guess maybe it's enough just to not recursively crawl this tree forever and like reset it back to multiple smaller trees. Is that better? Feels like I'm just doing the same work then. Anyway, let's see what we get. So NC becomes B, NBC, CN becomes CCN, and then again they split. So we've got MB, BC, CC, CN. Whereas before what I was doing is doing it all at once, going NC, NCN, NCNBC, so again this feels quite tree traversally, but there's some trick I'm missing in that I guess maybe I could skip the bit where I insert here. That's what I might be doing wrong. So this whole step isn't necessary because I could just jump from NN to NC and CN. And I do know that I only have to run 40 steps. So I could be just doing this for each tree at a time, but how do I even do that? And I could. I guess with this approach, I don't actually. All I need to do is preserve this pair staying with this pair, staying with this pair, but they don't need to be in the same order. You know, if I like reduce that down to just the pairs, CB, then I just need to figure out what count of characters is generated from each one of those. Is that better? Just feels like I'm going to end up with like a crazy big tree still here, and that doesn't feel right. Let's try. So it's this bit of inserting into a new polymer, this reliance on the next polymer being a string. Is that a problem? I'm not really sure. I might leave it here because I feel like I've spent a good 10 minutes thinking about it. I definitely don't know how to do it. Maybe I'll have a Google, which I've not done before, day 14, and see what people are recommending. Yeah, this is what I was doing. If I'm thinking of how to solve it in an instant time. Well, I'm going to put this in the chat, and so that you're not sort of not getting to see the actual answer. But yeah, apparently there's something more clever to do there that I may have frazzled myself out thinking about. So I'll leave it there anyway. I hope that was all right, and thank you very much for watching. Bye bye, everybody.